Hello everyone, I am Poonam Sharma, your science teacher. Welcome you all a new session with a new chapter, metals and non-metals. In previous classes, you people have studied about these metals and non-metals. You are aware of these terms. I hope still you remember few things about these metals and non-metals. But in this chapter, we'll study these two metals and non-metals in detail. So we'll study about these elements in detail. Now, as we all know, in our surrounding, there are so many elements are present. And out of those elements, some considered to be metals and some considered to be non-metals. But there are certain elements which have property of both metals and non-metals. And we call them metalloids. So metalloids are those substances which have properties of both metals and non-metals. So first of all, we'll discuss metals in detail. How will you define metals? Any idea what are metals? How can you define them? You must have studied in your 8th standard about this term. So I'll just recall your memory. Metals are those substances or those elements which are electropositive in nature. Electropositive in nature means they are, they lose electrons. So, and they have positive ions on them. So that's why we call them electropositive elements also. So metals are defined as those substances which have positive ions on them and they are known as electropositive elements. These metals are lustrous, they are malleable, ductile, they are good conductors of heat and electricity. So we'll study about these properties in detail one by one. And what are the examples of such metals? Any idea? Yes, such metals which we observe in our daily life: copper, iron, aluminium, gold, silver, and many more examples are there. So now let's study about these metals and their properties in detail. There are certain metals which are known as strategic metals. We call them strategic metals. And what are these strategic metals? Just write here, strategic metals. Strategic metals are those metals which helps in the economic development of our country, or we use them in aircraft. We use them in making parts of aircraft. So these are known as strategic metals. For example, titanium, zirconium. So we call them chromium. And we call them strategic metals because we use them in the economic development of our country, in country's defense. So that's why we call them strategic metals. Now there are certain physical properties of metals. First is hardness. As we know that metals are quite hard. If you'll take an example of copper, iron, aluminium, they are very hard metals. When you touch them, you can feel that hardness. And the reason behind their hardness is due to the rigid structure or the tightly packed arrangement of particles in them. That's why they are quite very hard. And there are certain exceptions in metals such as sodium, potassium and lithium, which are quite very soft and you just can't even imagine. They are so soft that you can easily cut with a knife. So just take an example of iron and sodium. You cannot cut iron. You cannot break iron easily. It is so tough. On the contrary, sodium is also a metal, but you can easily cut with a knife. So this is the exception in the metals: sodium, potassium and lithium. They are so soft that you can easily cut with a knife. And the second property of metals is strength. They are very strong. They have high tensile strength. For example, copper, iron, aluminium. And that's why we use them in making big structures, in construction buildings, or we use them in making utensils and vessels due to their more strength. Again, exception are Sodium and potassium, as I told you, they are so soft that we can easily cut them with the knife. Next is state. Metals are solid at room temperature except mercury. If you take an example of copper, so just keep copper in your room and it will not melt. So they are solid at room temperature. But if you take an example of mercury, we use mercury in thermometers. Nowadays we are using digital thermometer, but earlier we use mercury in thermometers for measuring the temperature of the body. And due to this tendency, because it is liquid at room temperature, that's why we use mercury in thermometers. Then next property is sonorous. Sonorous means sound. Whenever any metal hit to any hard object or hit to any floor, it produces some sort of sound. Copper, aluminium, iron, you can take any example. When you drop this metal on the floor, it produces some sound. So this is a property of metals. And that's why we use metals in making musical instruments. Because when these musical instruments in which we use strings, and when these strings vibrate or strike with each other, it produces some sound. And those strings are also made of metals. Another property is lustrous. Lustrous means shine. All metals are shiny in appearance. For example, silver, gold, they are so shiny. Copper, aluminium are also shiny in nature, iron also. But sodium and potassium, they are not shiny, they do not have any shiny appearance. But rest of the metals are shiny in nature. That is one of the most important property of metals. The next property is conduction. Heat and electricity. Metals considered to be good conductors of heat and electricity. Why metals considered to be good conductor of heat and electricity? Any idea about it? Why we call them metals are good conductors of heat and electricity? Yes, see, in metals, as I told you, they are electropositive ions. It means they have some free electrons in them. They are losing electrons from them. So their electrons are free, they are vibrating. So due to the presence of free electrons, they are considered to be good conductors of electricity and heat. They allow the heat to pass through them. You can take an example of a pan in your kitchen. So if that pan does not have any covering of wood or plastic over it, and if you touch that handle, you'll feel hot. So that is due to the good the property of the metal that they are good conductor of heat. They allow the heat to pass through them, and they are good conductor of electricity as well, due to the presence of free electrons. But if we increase the temperature, the electrical conductivity affects. And if we are increasing temperature, the electrical conductivity decreases. Let's see here how it happens. As I told you, metals have free electrons in them. These are positive ones, and they have free electrons which are moving. And when we pass heat to it, when we allow to increase the temperature, due to increase in the temperature, these positive charges, which are known as kernel, these positive charges starts vibrating, which acts like an hindrance or obstacle and stop the flow of electrons. As a result, the rate of conductivity decreases. So rate of electrical conductivity decreases, because electrical conductivity is directly proportional to the flow of electrons. More flow of electrons, more will be the rate of this electrical conductivity. But if we increase the temperature, due to these kernels, which are positive charges, they act like hindrance. When they start vibrating, they do not allow the electrons to move. So that's why we are saying if we increase the temperature, electrical conductivity electrical conductivity decreases. Then next property is malleability. Malleability is a property in which metals can be easily converted into sheets. Just take an example of aluminum foil, which we use in our kitchen and we use for packing food material. So just touch that aluminum, it is so thin. And another example of malleability property of metals are gold and silver. If you take an example of gold and silver, people use sheets of gold and silver for the decoration of sweets. So this is highly malleable. Gold is highly malleable metal. We can easily convert them into sheets. We can convert iron also in sheet, and that's why we use iron sheets in making big ships. When we want to construct big structures, we use sheets of iron, and this is due to the property of malleability. So metals show this property of malleability, that we can easily convert them into sheets. Now next property is ductility. Metals are highly ductile. It means we can easily convert them into wires. Electrical wires we are using in our home, they are made of copper and aluminium. They are good conductors, that's why we are using it, but they are highly ductile also. So that's why we use them in making wires. If we take an example of gold, gold is the most ductile metal. 1 gram of gold is equal to 1 kilometer of wire. Now just imagine how ductile it is. So metals are highly ductile, and out of those metals, silver is the most one. So that's why we use metals in making wires. Although silver also we can use, gold also we can use, but still we are not using gold and silver wires in making electrical wires, because they are quite very expensive and everyone cannot afford it. So that's why we use cheap metals which are easily available, and so that everyone can easily afford it. And if we are talking about electrical conductivity, I'll forget to tell you one thing. In electrical conductivity, silver is the most electrical conductive metal in nature, and mercury is the least one. It is most, and mercury, which is represented by Hg, it is least. So these are the exceptions in case of metals. Then melting and boiling point. All metals have melting and boiling point. They have high melting and boiling point due to the, again, presence of strong forces of attraction. Their melting and boiling point is quite very high. Except sodium and potassium, they have very low melting and boiling point. And you know, gallium and cesium, they have so low melting and boiling point that if you keep them on your palm, they melt. So they have such a low melting and boiling point. Otherwise, other metals they have high melting and boiling point. The next property is density. Most of the metals have high density. Here density means mass upon volume. See, all the metals have high density except sodium and potassium. They have low densities. And this is due to the tightly packed arrangement of particles. They are quite very dense. Then color. Most of the metals are gray in color, or you can say shades of gray are there. For example, aluminium, iron, silver, they all have gray shades except gold and copper. Gold, as you know, it is yellow in color, and copper, it's somewhat brownish or reddish in color. So these are the exceptions in case of colors. Now, apart from this, gold is least reactive, and that's why we use gold and silver in making ornaments. Gold, silver, platinum, they are rarely found metals, and that's why they are very expensive. They do not react easily, and we use them in making ornaments. So these are the physical properties of metal. Physical properties means how these metals looks like, or how they are, how what kind of shape they have, what kind of structure they have, what properties do they have. So these are the physical properties which I have discussed with you of metals. Now let's come to the chemical properties. Here, chemical properties means when metals react with any other substances in nature, it results in the formation of certain products, and those properties are known as chemical properties. So metals, as I told you, some metals are highly reactive, some are less reactive, some are least reactive. So depending upon their reactivity, they'll react with the other substances in nature accordingly. And first is reaction with oxygen. So when metals react with oxygen, they form metal oxides. Whatever metal reacts with oxygen, it always results in the formation of metal oxide. Whether it is most reactive or less reactive or least reactive, in all the cases, it always forms metal oxide. Let's look at the example. Reaction of potassium with oxygen. When potassium reacts with oxygen, it reacts vigorously. It is highly reactive metal, so it immediately reacts with this oxygen, which results in the formation of potassium oxide. Similarly, sodium is also highly reactive metal. So when it reacts with oxygen, it also results in the formation of sodium oxide. Similarly, if we talk about lithium, lithium is also highly reactive. And these three, lithium, sodium and potassium, they are highly reactive metals. They react vigorously. Vigorously means quickly with oxygen, and they all result in the formation of oxides. This potassium and sodium being highly reactive in nature, we always keep them in kerosene oil. And the reason behind for keeping them in kerosene oil is their highly reactive nature. If we'll not keep them in kerosene oil, if we leave it like this, they rapidly react with oxygen and results in release of high amount of energy or causes severe accidents. So that's why we always keep them in kerosene oil. But if we're talking about lithium, lithium is also highly reactive, but we never store it in kerosene oil. And the reason behind is because the lithium density is less than that of kerosene oil, and it keeps floating on it. That's why lithium cannot be stored in kerosene oil. So out of these three, only these two can be stored in kerosene oil. It's 1 mark question. Why sodium and potassium stored in kerosene oil? And the answer is because they are highly reactive in nature and they react vigorously with oxygen. So that's why we always store them in kerosene oil. And lithium never stored in kerosene oil because it is less denser than kerosene oil and it keeps floating on it. The next is reaction of copper metal with oxygen. Copper is not that much reactive. It is less reactive than sodium, potassium and lithium. But as I told you, it is a metal. If it reacts with oxygen, it results in the formation of copper oxide. So it does not react with oxygen at room temperature, and when burned in air, it gives oxide. So we use copper vessels. And if we leave copper vessels for so many days untouched, so it develops a greenish layer over it. Greenish layer. This is due to the reaction of copper with oxygen. Although this reaction will take so many days, but it will react with oxygen not at room temperature but at high temperature. But it results in the formation of copper oxide. And if we talk about silver, gold and platinum, they do not combine with the oxygen even at high temperatures also, because they are least reactive. And that's the reason we use these three metals in making ornaments, because they do not react with oxygen and it will not react with our skin also and will not get any kind of allergy. So these are best ornaments, or these called to be best friend of every female. These metals are the best friends because we use them in making ornaments. But there are certain exceptions in metals. First, I'll talk about aluminium. When aluminium reacts with oxygen, again, it results in the formation of aluminium oxide. And this aluminium oxide has the tendency to react with both acid and base. So when it reacts with both acid and base, it results in the formation of salt and water. And this kind of reaction, if you remember, is known as, just write down in the comment box, what do we call this reaction when acid and base react with each other? I'll leave this question for you. Write down this answer in a comment box. When metal react with acid and base, or when acid and base react with each other, it results in the formation of salt and water. And those metal oxides, when they react with both acid and bases, are known as amphoteric oxides. So here you can see the reaction when aluminium oxide reacts with hydrochloric acid, it results in the formation of aluminium chloride, and it results in the formation of sodium aluminate. So here you can see when aluminium oxide reacts with it, it results in the formation of aluminium chloride and sodium aluminate. So this is acid, HCl, hydrochloric acid, and this is base, which is NaOH. Now, generally metals oxides are insoluble in water, but there are certain metals, metal oxides, which are dissolved in water and they give alkalis. Now tell me, what are alkalis? Write in the comment box what are alkalis. Here just look at the example. Sodium oxide, when it reacts with water, it results in the formation of sodium hydroxide. And here we have potassium oxide. When it reacts with water, it results in the formation of potassium hydroxide. Okay, and these are known as alkalis. So I ask you, what are alkalis? So alkalis are those bases which are soluble in water. So the bases which are soluble in water or which dissolve in water are known as alkalis. Okay, then at normal temperature, some metals, when they react with oxygen, they form a layer over them, and this layer protects them to get oxidized. And such examples are like magnesium, aluminium, zinc, lead. So when we leave them in an open air, they comes in contact with oxygen, they form oxide layer over them. And if you remember, we have discussed this example in previous chapter. So before burning magnesium ribbon, we always clean it with a sandpaper to remove the magnesium oxide layer so that it can burn easily. that magnesium oxide layer which develops on the magnesium when it comes in contact with the oxygen. That magnesium oxide layer protects the rest of the magnesium to get oxidized. Similarly, case with aluminium, zinc and lead also. They'll also form this oxide layer and they prevent the further metal to get oxidized. And oxidation means when metal come in contact with oxygen, which results in the rusting or the wastage of those metals. So due to the formation of this layer, they get protected. And let's take an example of iron, which is considered to be very strong metal. It does not burn on heating, but it will take iron fillings, which is in the form of fine powder of iron. So when we take iron fillings, which is in the fine powder form, so when you we try to burn them, they burn vigorously and they scattered in flames. And another metal is copper. When copper, we need to try to burn it. It will not burn very easily. But hot metal develops a coating of black colored copper oxide. So when you try to burn copper, it is not easy due to its high melting point. But if you burn it, that hot metal, then it develops this copper oxide layer which is black in color. And silver and gold do not react with oxygen even at high temperature. That I've already told you. That's why we use them in making ornaments. So these are the reaction of metals with oxides, and these are the exceptions which I have already discussed with you, like aluminium, which is amphoteric oxide. Now I'll ask one question to you. What are amphoteric oxides? Just write in the comment box what do you mean by amphoteric oxide and give an example of such kind of amphoteric oxide. And another question I'll ask you, why we keep sodium and potassium in kerosene oil? Just answer these two questions and write your answer in the comment box. Very important method is anodizing. Generally, we use this anodizing method to prevent the metals from getting rusted, or it gives good texture and it makes the metals corrosion resistant, and it improve its strength as well. That's why we use this anodizing method. In this anodizing method, we generally use aluminium. The layer of aluminium deposits on the layer of any other metal, and this can be done by passing electricity through the setup. So here we have taken two electrodes, cathode and anode. So when we have taken two electrodes and when electricity is passed through it, the anode is aluminium. So that aluminium start depositing on the metal, and once all the aluminium get deposited on it, so we'll stop the reaction and then we'll get the layer of aluminium over that metal. In this solute, this solution which we are using while performing this anodizing technique is dilute sulfuric acid. So this is how we perform this anodizing technique, and it is an electrochemical process. Electrochemical means by passing electricity, chemical reaction takes place, which converts the metal surface into decorative, durable, corrosion resistant and anodic oxide finish. It gives good texture to the other metal. And the most commonly used metal in anodizing is aluminium. And another metals which we can use, magnesium and titanium also. So this is on an anodizing technique. Now, reaction of metals with water. So when metals react with water, it results in the formation of hydroxide. So when they react with oxygen, they form oxides. But when they react with water, they form hydroxide, and hydrogen gas is liberated. This is hydrogen gas. So whatever may be the case, whenever any metal react with water, it always forms metal hydroxide and hydrogen. Although different metals have different tendency to react with the metal. Those which are highly reactive, they react rapidly with water. Which are less reactive, they'll take time, or sometimes they'll not react with cold water. So we'll take hot water in those cases. So we'll study about these reactivity, rate of reactivity of metals with water later. This is how metals react with water. Now, I hope till here it is clear to everyone. I'll give 2 questions to you as a homework. This is your homework. And write down their answers in the comment box if you know the answer. Why we store sodium and potassium in kerosene oil while lithium cannot, although it is also very reactive. Second question is, give the reaction between aluminium and oxygen. And third question is, what are amphoteric oxides? So just write down these answers in the comment box. This is question number 1, 2, and 3. If you know the answer, quickly write down the answer in the comment box. And we'll discuss these questions in next class. So till then, bye and take care.